Everyone, welcome back to the channel. So here today we are going to be graphing exponentials. Let's say you have y should be equal to 2 to the power of x. So how do you graph this one? So let's look at the behavior of this graph. So let's come up with plots. We have our x and our y. If our x value is equal to, let's say, -2, -1, 0, 1, we can go as far as 2 and our 3. Let's see the behavior. If you put -2 where x is, you're going to have y is equal to 2 raised to the power -2, which will be equal to, this is the same as 1 over, since negative adds a over, we have a 2 to the power 2, which will be 1 over 2 to the power 2 is 4, which will be 0. We are going to have, we add 1, we add a 0, 10 divided by 4 is 2, the remainder is 2, we add a 0, 20 divided by 4 is a 5. So this will give us a 0.25. If we put a -1 where x is, we are going to have our y should be equal to 2 raised to the power -1, which will be y should be equal to 1 over 2, which will be equal to 0.5, like that. So we are going to get a 0.5 here. If we put 0 there, we are going to have y is equal to 2 to the power 0, which is equal to 1 there. Then if we put our 2 there, we are going to have y is equal to 2 to the power of 2, which is equal to 4. So we have a 4 here. Here we are going, if we put 1 there, we are going to have 2. If we put 2 there, we are going to have 4. If we put 3 there, we are going to have a 8. Yeah, 8. So have you seen the behavior of this graph is that no matter what value you put, it's always going to be a positive value. We can say that it's always above 0. So meaning to say that is our asymptote. That is the line which your graph will not touch. So let's plot this. So let's begin with our 0, 1. So where x is equal to 0, it is along the y-axis. 1 is here. So our 1 is here. Then our next point is 1 is equal to 2. So 1, 2 is here. Then when we go to our 2, when x is equal to 2, y is equal to 4. So we are going to have something here. Then when our x is equal to 3, y is equal to 8, like that. Then as we go on, -1, it is reducing. -1 is 0.5. 0.5 is half of that value. Even 0.25 is half, so it's more like it's decreasing, but it does not go below this where x is it does not go below where y is equal to 0. So along this line, y is equal to 0, it does not cross this. So when we graph the equation, it will pass at 1 like that, pass like that. Yeah, so this is what we are going to have, like that. So this is generally how the graph looks. So it continues like that, it continues like that. So this is the graph of our y should be equal to 2 to the power of x, like that. So now it's not that you are going to be using these coordinates to come up. You should just know the graph. So just know for any exponential graph, if you put 0, it will pass at 1. So if you have 3 to the power x, it will always have, if you have 3 to the power 0, it will always pass at 1, like that. So now for the domain, it's important to always mention the domain. So the domain of this graph is, so as you can see, there are x values this side. It's continuing. So domain is the x values. So the domain is -infinity to +infinity. The range, on the other hand, are the values that are being produced. So in this case, you can see that a 0 is not touched. So we are going to use an open circle and say 0. It is moving up like that. So this graph will be to the +infinity, like that. So it's not touching the 0. That's why we do that. So likewise, if we have our y should be equal to, let's say we have our y is equal to -2 to the power of x. So we are going to graph by translation, meaning to say we are moving the graph. So we have, remember the graph of how it looked. We have a 1 there, we have a 1 here, so it's passing at 1 for that equation. So we just need this point and do this. So it's going to continue like that. Then on the other hand, this graph is our y should be equal to 2 to the power of x, but they want negative. So what the negative does is it flips the equation. So if this is 1, it will now be at -1. So it is at this point. So this point, what we are going to do is we are going to have this graph as our actual graph. It is going to look like that. So it is just the same graph that has been rotated like that. So let's move this point a bit. So let's put, so this is our -1. So as you can see, each point, even this has just been reflected, or rather rotated. It's this point, this, it's this like that. So it's more like you have just rotated. So this is how you graph the graph of y should be equal to -2x, like that. So if there is a negative here, it rotates the graph like that. So that means to say, if you have your 2 raised to the power -x like that, then this rotates the graph in the, so if it was here, so as you can see, this is 2 to the power x, 2 to the power -x will rotate the graph to look like something like this. Yeah, like that. So this is your graph of your y should be equal to 2 raised to the power -x, which is going to make sense as we look at y is equal to 1/2x. As you can see, this is exactly the same graph, because -1, this, if you have, let's say, y is equal to 2 to the power -x, this can be written as y should be equal to 2 to the power -1 times your x, like that. This is still going to give you y is equal to 1/2. Then we have the power of x, like that. So this is still the same. That's how come this graph is rotating. You are going to see as we look at other graphs. So that means to say another graph might look like something like this. Another graph might look like something like this. This graph is our y should be equal to, we have rotated this graph, it is 2 to the power, not 2 to the power, but -2 to the power -x. So this is the graph. Let's move on to our, so if we are required to say the domain of this graph, so this graph has got the domain. So the domain of an exponent is always -infinity to some positive infinity, but the range changes. So if we are looking at this equation, the smallest value is 0, which it is not touching. So we are going to say 0, so we can see that it's going down, so it is having negative value. So we have 0, -infinity, like that. So that is our range there. Let's look at our next problem. So from what you have seen, these graphs are increasing functions. So like for example, if you have something like this, this is an increasing function. As x increases, y is also increasing, like that. So it can continue like that. As x reduces, also y is reducing in that case. But what happens if we have a number that is in between? Let's say 0 is less than our b is less than our 1. B in this case is the base. Like for example, if you have your f of x is equal to b to the power x, b can be equal to, let's say, 2, not 2. But if b is less than b is greater than 1, but it is less than, or it is greater than 0 but less than 1, then that means to say you're going to have your b value will be equal to 1 over your 2, like that, as your value, like that. In this case, the function is a decreasing function. That means to say for each increase in x, there is a reduction. So the graph looks like this. So generally it looks like this. Same graph, but just rotated. So remember, this graph was the one that was I was even saying that this is the same as 2 to the power -x. But in this context, we can say this is which is still the same, 1 over 2 like that. We can have to the power of x like that. So this is the graph. It passes at the same point because 1 over 2 to the power of 0 will always give you 1. So this point is equal to positive 1 like that. So if you are provided with a graph and you're required to graph your y is equal to 1 over, let's say, your 3 to the power of x, this is still the same. So you are just going to look at one point, but since this value is less than 1, but it is in between 0 and 1 over 3 is equal to 0.333. So that means to say the graph will look like this. So the graph will look like this. So we have our positive 1 there. Then the graph is moving like that. So basically that is how you graph 1 over 3 to the power of x like that. With that said, let's graph a very simple one. Let's say you have your f of x is equal to 2 to the power of x minus our 3 there. So if you have this problem, how do you handle it? So we are going to graph by translations. That means to say we are going to do this. So we are going to do this. Remember, this is 2, meaning to say the graph will be moving. It's an increasing function, so it will be moving like that. So this is our graph of our y is equal to 2 to the power of x. Now you are going to say, this is a shift in the y direction, meaning to say you are subtracting 3. So this point is 1, so that means to say 1 minus 3. So now get this. If you have negative 3, that means to say, remember it's not crossing 0, it means to say 0 minus 3 will be at negative 3 like that. So it is going to look like something like this. So this line, it should not cross it because we have moved the line which it is not crossing. So we are going to have 1 minus 3. So if you have 1 minus 3, it is going to give you negative 2. It means to say this is moved to negative 2 like that. So we are going to have this. Then what we are going to have is the same graph. So it is going to look like this. It is going to look like this, not a straight line. So this is the graph that is required for y should be equal to 2 to the power of x minus our 3 like that. So this is our graph for that problem. So the domain, remember the domain for this one is negative infinity. It is any x value, so it is continuing in both directions. The range on the other hand, so the smallest is a negative 3, though it's not touching. So we are going to say negative 3 with an open circle, comma. We are going to be moving up. So this will be positive infinite like that. So that's the range for that problem. If we have, let's say now we have y should be equal to 2 to the power of x minus 3. So this one is a shift in the y direction or in the x direction. If it is affecting, if it is attached there, it means to say it's a shift in the x direction. It's more like you can just think of it, it's connected to x, so it will affect x. This number was not connected to x, so it affected the y. So we are going to have something like this. We are going to have something like this. So just remember the mother graph. Just remember the mother graph. So we have 2 to the power x. 2 to the power x is equal to, it is going to pass at 1. So 2 to the power x, remember it is an increasing function like that. An increasing function like that. Then, so this is our y should be equal to 2 to the power x. So that means for us to graph the 2 to the power x minus 3, we just move the graph in the x direction. So if our x value here is 0, it means to say we have to move 3 units. So we have 1, 2, and 3 units, which will be somewhere here. So when we do that, we are just going to graph the same graph, but it has just moved like that. So the graph is looking like that. So we have that graph. So this is the graph of our y should be equal to 2 to the power x minus our 3, like that. So that is how we graph that one. You can also verify to say this is less than 1, because if you have y should be equal to 2 to the power x minus 3, at this point x is equal to 0. At the y-intercept x is equal to 0. That means to say y is equal to 2 to the power 0 minus 3, which will be y should be equal to 2 to the power negative 3, which will be y should be equal to 2 to the power 3 is the same as 1 over 2 to the power 3, which will be 1 over 8. And 1 over 8 is equal to 0 point. You add a 0, it will be 1. The remainder is 2. 20 divided by 8 is 2. The remainder is 4. 40 divided by that is 5. You can tell that this is 0.125, which is this point, like that. So likewise, the domain is not affected. The domain in this case is negative infinity to positive infinity. The range is also going to be, the smallest is 0. The highest you can go is a positive infinite, like that. Let's move on to our next one. Let's do some translations to this graph. So if you have something like this, so what we are going to have is let's put it here. So what we are going to have is the first part. Let's graph this 3 to the power x. So we know to say we are going to go at 1. 3 to the power x will be like this. So it will look like something like this. So this is our 3 to the power x. Then the other thing is we are going to have something that is like this. So this is our y is equal to 3 to the power of x. Now let's offer a translation in the x direction, which is our plus 1 there. So one thing that I forgot to mention was, so as you can see, if the graph is having an negative x, it means you say x minus 3 is equal to 0, so x will be equal to 3. It means to say it will move to the right. Then if it is positive, it means to say it will move to the left. So in this case, it's x plus 1, which will be equal to 0. X is equal to negative 1. So that means to say you're going to go at negative 1, which is here, like that. Then draw the same graph like that. So we are going to have, let me wrap this a bit. We are going to have a graph that is going to look like the same graph, but due to the fact that it has moved, even this value will change like that. Now this graph will be our y. This will be our y should be equal to 3 to the power x plus 1. But it's important to know the intercept in this case, since you are still translating your graph. So in this case, this intercept, you can find it by saying y is equal to, we have our 3 to the power x plus 1. At the y-intercept, x is equal to 0, so we are going to have y is equal to 3. Then we have 0 plus 1, which will be y should be equal to 3. So y is equal to 3 to the power 1, which is basically just 3. So it is passing at 3. So it is passing at positive 3, like that. Then from here, what we are going to do is we are going to subtract. So to graph, minus 2 means subtract 2 from every coordinate. So 3 minus 2 is equal to, let's not forget something that is very cardinal. So this was the line that was not being crossed. So 0 minus our 2, it will give us a negative 2. So that means to say the new line that should not be crossed is a negative 2. So if that's the case, we are going to have, so this is positive 1, like that. So what we are going to get is this. So looking at the last graph that we have translated, it's this one. So you have to always look at the last graph. So this one is our y should be equal to 3 to the power x. Then we subtract 2 from the last graph. So we have 3 minus 2 is 1. So it's going to land here again. Then we have what other point? The other point is this one is 1. 1 minus 2. 1 minus 2 is going to give us a negative 1. So we have a negative 1 here. So our final graph will look like something like this, which will be something like this. So this is our graph of our y should be equal to 3 to the power x plus 1. Then we have minus 2 like that. So this is our value for that problem. So for this problem, what we are going to have is we are going to get something like this. So if you have 1 over 3, it means to say it's a decreasing function, meaning as x increases, y decreases like that. So we are going to have something like this. Let's say it passes there. So that is, this will form our y is equal to 1 over 3 to the power of our x like that. So it's not crossing there. Then what we are going to get is, for the second part, if we subtract 1, which is x minus 1, it means to say x minus 1 is equal to 0, x is equal to 1 if this goes this side. So our x is equal to 1 at this point, so we are going to move 1. So here it is, we have this point, it is the one that is being moved. So it will be moved to this point like that. So this graph, if we are to repeat it, it's going to look like something like this. From here to here, it's just being moved like that. So we are going to have something that is going to look like this. Like that. So this will be, you need to find what is the value of this. So y is equal to 1 over 3 to the power of x minus 1. So at this point x is equal to 0, so y is equal to 1 over 3 to the power of 0 minus 1. This will be y should be equal to 1 over 3 to the power negative 1. So if you have a negative power and a fraction, they just interchange. So this will be, your y should be equal to positive 3. That's the easiest way. Just interchange them if you have a negative power like that. So that means to say the new intercept becomes at positive 3 like that. So we are going to have something like this. Oh, we were finding the intercepts for this equation. So our 3 is here. So this will be our y. Where is the best line to name it? So this will be, okay, I need the way to, the best place to label it. So we have y should be equal to, we have our 1 over 3 to the power of our x minus 1 like that. Then finally we add 2. So the line that wasn't crossed was 0. So 0 plus 2, it will be, 2 is somewhere here. Now there is a lot of drawings. Let me clear it up a bit. So this is what we have. Like that. So this is our 2. This is the line that won't be crossed. So if we have a 2 there, it means to say we are going to add. So 3 plus 2 will give us 5, which is somewhere here. So we are going to have a 5. It is going to pass at 5. Then the graph will just look the same, but it's just shifted up like that. So we are going to have something like this as our final graph, but it will not be able to cross that line. So this is our graph of y should be equal to, we have 1 over 3 to the power of, we have our x minus 1, then we have plus our 2 like that. So this is our graph for that problem. So if I can just do this, so this is our graph for that problem, and that is how we go about that one. Let's move on to our last problem. Before we do, let's say the domain. So the domain is unaffected in this case, so the domain is equal to negative infinity to the positive infinity, like that. Then the range will be equal to, in this case, 2 is the line that is not being crossed, so we are going to say the smallest is 2, it is not being dashed, open circle, then it's going up, so to the positive infinity, like that. So that's the range there. Last but not the least, let's look at our y should be equal to e to the power of x minus 1 plus our 1, like that. So we are going to have something like, for this one, e is the value, this is the value of e, meaning to say it is greater than 1, and in this case, if it is greater than 1, it is an increasing function, in the sense that it is positive and it doesn't have, it is greater than 1, like that. So we have 2.72, that's the value of e. So to graph this one, it is not going to be different. So e to the e, if we have an equation like this, it is still going to be the same. We are just going to draw like that. Okay, so if we have that, we are going to say this is an increasing function, therefore it is going to be, as x increases, it is going to be going like that. So we are going to have something like this. So this is already, this will be our equation, which is saying that, this will be our equation, which will be saying that we have our, okay, I'll label it. So this is the equation that is saying that we have our y should be equal to e to the power x, like that. Then if we add the shift negative minus 1, it will be x minus 1 is equal to 0, so x is equal to positive 1. So this is going to go at x is equal to positive 1, so it will move. When it moves there, what we are going to have is, it is still going to be drawn the same way, like that. Now we cannot approximate what the value here is, because if you have this value, it will be e to the power of, at this point x is equal to 0, so you are going to have e to the power negative 1, and this is the same as 1 over e, and e is equal to 1 over 2.72, of which you cannot do this properly without a calculator, but we're just going to know that it's somewhere there, but less than 1. Then what we're going to do is, after we have done that shift, we are now going to, so what do we have? We have, this is y is equal to e to the power of our x minus 1. Then we are going to add 1. So this plus 1, remember this is 0. Let's say if it's 0.2, 0.2 plus 1, that will give you somewhere 1.2, meaning to say it's greater than this one. So we are going to say plus 1 will be somewhere here. Then the other thing is, so this is going to come here, then this 1 plus 1 is 2, so 2 is somewhere here. So if we have a 2 here, then all we have to do is we are just going to graph the equation. Just be careful, don't forget plus 1 means this equation shall not be able to cross this one. So we are going to have something like this. Then it's going to pass at 2, like that. So we are going to have our y should be equal to e to the power of x minus 1 plus 1, like that. So that is that equation. So that is how you graph these equations. Thank you very much for watching. Hope you would like, subscribe, and share for more. See you in the next tutorial.